My name is Ayoung.
And my name is Minlu, and this is our project.
An effective non-wasteful sprinkler. So the problem is that when we use sprinklers during summer, as much as 50% of the water we use is lost due to wind evaporation and runoffs. Our question is, how can we reduce the amount of water wasted in sprinklers?
Our hypothesis is by changing the nozzle's opening's shape and size, we can alter the droplets and spread. Our engineering goal is to create a sprinkler that makes a uniform spray pattern and produces big droplets. So our procedure is to first gather the necessary materials, then we'll assemble the simple base of the sprinkler. After that, we'll create a holder for the sprinkler, and then we'll design and 3D print the nozzles. As you can see, our sprinkler and the holder can be seen in the first picture on the top.
After we 3D print the nozzles, we'll attach the nozzles to the sprinkler, place the sprinkler on open ground, and then we'll spread 6 cups in a line in front of the sprinkler and run it, passing the cups 3 times. Compare each nozzle to see which is most effective will be next, and then lastly we'll present our findings as a table and organize data into a graph. The pictures 2 and 3 shows how we set up our experiments.
So we will collect our data in a chart too. So the first chart is raw data. So the cup number is which cup we're weighing. Before is the weight of that cup before the sprinkler sprays it, before any rounds. Round one would be the weight of the cup after the sprinkler sprays it, and then round two would be the weight of the cup after round two, and so on. So calc data is basically the data that was calculated out. So distance is the distance between the sprinkler and a cup in feet, and round one is the amount of water sprayed into the cup during round one. Round two would be the amount of water sprayed into the cup during round two, and so on. The average is the average amount of water sprayed into the cup during only one round on average. And then the MAD is the mean absolute deviation, which is the average deviation from the average, and it just shows us the error basis.
So these graphs show the amount of water sprayed on average. The dotted line is the overall trend. The x-axis represents the distance between the cup and the sprinkler, and the y-axis is the amount of water sprayed. As you can see, the commercial nozzle is not uniform and has a varied spray. However, our nozzle, on the other hand, is much more uniform and stable.
In conclusion, commercial nozzles are very ineffective with misty and uneven spray along the distance. And then we also know the bigger the opening in the nozzle, the bigger the droplets.
Tilting the opening can improve the weight, as can making the opening smaller. Finally, among our design nozzles, a tilted rectangular slit is the most consistent.
The images on the left are the nozzles that we designed, except for the first one, that is the commercial nozzle. Thank you.